Hi, I'm Avi Goldfarb. I'm here to talk about the economics of AI. It's based on my forthcoming book, Prediction Machines, with Ajay Agrawal and Joshua Gans. And the essence of the book is to try and understand and cut through the hype around AI. So we hear everywhere you go, there's this exciting new technology. It's really changing everything. It can transform business. It can transform society. And what our job is, and what my job is here, is to cut through the hype and give you a sense of what's really going on. And how did I get here? What's the background? Well, I'm an economist. I've been at the University of Toronto now for over 15 years. But I teach in a marketing department. And for most of my career, I've been teaching statistics. So it's this strange combination: economics, marketing, stats. And at the University of Toronto a few years ago, I found myself involved with an incubator, a program we have for helping early stage startups scale, called the Creative Destruction Lab. And in the Creative Destruction Lab, starting around 2012, we saw this trickle of companies calling themselves AI companies. And because we were in Toronto, where a lot of these technologies were invented, we started to see the newest, most exciting applications through our lab. And that trickle in 2012 started to become a flood by 2015, 2016. And Ajay, Joshua, and I had this front row seat for understanding business applications for these new technologies. And what we've done is distill the insights that we had into our book, and for the next little while, for this conversation with you. And so the basic idea, the essence of how you should think about any technological revolution is, as an economist, to think through a drop in the cost of something. Okay, so I made my career, and so did Ajay and Joshua, studying the previous massive technological change, the internet. And in 1995, there was this exciting new technology. It seems to be transforming everything. And it was called, it seemed to be, it's changing business. It was the year that Netscape had their IPO, valued at over $1 billion with not a penny of profit. It was the year Bill Gates wrote his tidal wave email saying, we need to transform our company, Microsoft, to take advantage and pivot toward this new technology. It was the future of computing. And everybody started talking about a new economy. But there was one group of people that didn't really think there was a new economy, and that was us. That was the economists. We said, no, it's not a new economy. It's the same old economy, but the cost of some things has fallen. And in particular, when you think about the internet, search and communication are easier and cheaper than they were before. What does that mean? We're going to have more search, more communication, and that can be transformative for industries where search really matters. Now let's jump back at technology and think about the semiconductor. So if the internet's all about a drop in the cost of search and prediction, what does a semiconductor do? Well, a semiconductor really does one thing. A computer does one thing. A computer adds. That's it. Computers do arithmetic. And if you're thinking about what's really going on, how do we understand this transformative technology that seems to have changed the world, well, you've got to remember all it does is arithmetic. And so you can think about computing, you can think about the semiconductor as a drop in the cost of arithmetic. And once you understand that, you say, well, simple economics tells us what happens when the cost of something falls. When the cost of something falls, we do more of it. Economists call this demand curve sloping downward. But the simple way to think about it is when the price of something is lower, we're more likely to buy it. And so when the cost of arithmetic fell, we started to use more and more arithmetic. And at first, we used machine computing for the same applications we used to have humans do arithmetic for. So the first applications were artillery tables. We had cannons. They shot cannonballs. We tried to figure out where the cannonballs were going to land. And that's an arithmetic problem. And so we had machines do that instead of humans in the military. And then machines started to do accounting. If you ask an accountant what they used to do, they used to spend their time adding. They literally did arithmetic, adding and subtracting columns of numbers. Accountants don't do that anymore. Machines do that. Machine computers took over the job of human computers. But what happened as arithmetic became cheaper and cheaper and cheaper and cheaper and cheaper, that we started to see all sorts of new applications for arithmetic that we might not have dreamed of. It turns out games are an arithmetic problem. Music is an arithmetic problem. Images, even pictures, are an arithmetic problem. Why? Because once arithmetic is cheap enough, we found all sorts of new applications that we might not have dreamed of. Okay. That brings us to AI. So what's this excitement in thinking about the new technology, artificial intelligence? Well, artificial intelligence is a technology that's been on the cusp of being transformative for decades. What's happened now, the reason we're really talking about it in 2018, and we didn't have this excitement in 2008 or 1998, is because of a particular application of AI, and that's prediction technology. What you should think about AI is, it's a drop in the cost of prediction. And just like when arithmetic got cheaper, we started to find new applications and more exciting applications of arithmetic. When you think about AI, the recent excitement around AI, which is a suite of technologies together called deep learning and machine learning, they're prediction technologies. They fill in missing information. They take information you have, called data, and replace it and find information you don't have, missing information. So prediction you should think of as the cost of filling in missing information. Sorry, the process of filling in missing information. And so once you understand AI as prediction technology, the machine learning as prediction technology, then you can see from basic economics what's going to happen. Just like with arithmetic, when the cost of prediction falls, we're going to do more and more prediction. And so the first applications of machine prediction have been exactly those same applications that we saw with human prediction, right? So the first applications of machine prediction are going to are in insurance. How do we price risk properly? That's a prediction problem, and machines are now doing that and replacing humans. Bank loans. So it's a prediction problem whether someone's going to pay back their loan or not, or someone's going to default. And we used to have humans do that, or some algorithms do that. Increasingly, that's done by machine learning, by AI. It's a prediction problem. But what's happening as prediction gets cheaper and cheaper and cheaper and cheaper, we're finding all these new applications for prediction that are less obviously prediction problems. It turns out diagnosis, medical diagnosis, is a prediction problem. The doctor takes information on your symptoms and your characteristics and fills in the missing information of the diagnosis, of what's wrong, what's causing the symptoms. And so once machine prediction gets cheaper, we recognize that diagnosis is a prediction problem. But as prediction's gotten even cheaper, we found even new applications of arithmetic. Object identification is a prediction problem. How do we recognize an object? How do we recognize a face? We take in the information, the signals, the visual signals, and fill in the missing information of a label and a meaning. And even autonomous driving has turned out to be a prediction problem. And this is a tricky one, and in some ways a bit of a scary one. What are you predicting in autonomous driving? You're predicting what a good human driver would do. And so the insight that you can transform driving into a prediction problem by predicting what a good human driver would do can be applied in all sorts of places. And as prediction gets cheaper and cheaper and cheaper and cheaper, we will see all sorts of new applications of prediction that we might not have dreamed of. We're only a few years into this change, and we're compared to decades into computing, and we're still finding new applications of cheap arithmetic, and we should expect many more years of invention and innovation of new applications of machine prediction. So once you understand that AI is prediction, the question is, well, okay, what are the consequences? Econ 101 already tells us, well, demand curves slope downward. When the price of something falls, we do more of it. So you might remember learning a long time ago that when the price of coffee gets cheaper, we buy more coffee. But there's two other important aspects to that. Another lesson from Econ 101 is that when the price of coffee falls, we buy less tea. And so you should think about that as we're doing more machine prediction, we're going to be doing less human prediction. The third aspect of it is as the price of coffee falls, cream and sugar become more important. We buy more cream and sugar. And so the question around prediction is how do we think through the complements? How do we think through the things that become more valuable once prediction gets cheaper? And how we do that